one of these days, one of these videos is going to go viral. It's just, I'm just going to present it so well that you're going to share it with all your friends.
Yep.
Like, this is amazing. You've got to watch this guy explain operations of complex numbers in trig form. It's incredible. Find the product of the two complex numbers r cosine A plus I sine A and r2 cosine B plus I sine B. Another way to write this, and this is how it relates to number 12, so that's r cis A, or excuse me, r1 cis A times r2 cis B. On number 12 in worksheet 1, we just didn't have r1 and r2. It was just the cis parts. Okay, product, so that means multiply. So, goodness, this is going to be r1 cosine A plus, I'm going to leave the r1 off of that. I'm not going to distribute the r1 because I'm going to multiply the r1 and r2 and put them out front. Okay, so there's just like rewriting what was already given, but instead of, the only step there is, instead of saying product, we're going to multiply them. Okay, that's a lot of stuff going on there. But I think I want to do the r1 times r2 and just put that out front. That way I can FOIL the rest of that stuff. But yeah, let's leave r1 and r2 out front. So r1, r2 out front. And then what's left on the inside is cosine A plus I sine A times cosine B plus I sine B. Yeah, because all I did was move the r1 and r2 out front. So let's leave the r1, r2 out front. And what are we going to have to do with this times this? FOIL it. So it's going to be ugly because I'm going to have sines and cosines all over the place. Not difficult, just like be careful, like record keeping, right? Just be neat. Make sure you've kept all the terms there. So first would be cosine A, cosine B. Outside would be plus I cosine A sine B. Inside would be plus I sine A cosine B. Yeah, that's right. And then last, I times I is I squared, which is -1. I squared is -1, so minus sine A sine B. It's me trying to avoid writing a whole nother line just to accomplish the I squared equals -1 thing. Okay, that's kind of a mess. Let's group some things here. So let's group the not I stuff together, and then we'll group the I stuff together after that. So the not I stuff would be cosine A cosine B minus sine A sine B. Yeah, I'm not really doing anything other than like rearranging the order here. And then the I stuff, I think I'll factor out the I even, is cosine A sine B plus sine A cosine b. Good so far? Try to go slow enough for you to see what we're doing, not just frantically copy down everything I write down, but to understand what's happening. You're like, ugh. Okay. It's like, well, why did that help? Well, if we're really paying attention, we might remember that that looks like something. There was a property of sines and cosines and A's and B's that were like, that was the answer. Do you remember what that was? Cosine of A plus B. Cosine of A plus B. And kind of the same thing over here. If we're really paying attention, and this one's tricky because it's like one of each, and it's maybe in a different order than we're used to seeing. That's the sine of A plus B. Okay, so we're going to skip ahead to this next line here. So again, what we started with was R1 cis A times R2 cis B. That's what all of this stuff was, that this long process we're working through. So the answer is R1 times R2. That's the easy part. Multiply the R's. But look what's left. Cis of A plus B. Which is kind of wild that if you multiply R1 cis A times R2 cis B, we multiply the R's. Okay, that makes sense. This is a multiplication problem. But we add the angles. That's kind of weird that it works out that way. Multiply the R's and add the angles. So all this stuff that we went through here, you're not going to have to do that again. That was just like proving this line where all you have to do is multiply the R's and add the angles. Now we could go through the same process with division, but that would be kind of annoying. If we had R1 cis A divided by R2 cis B, what do you think we do with the R's? Careful, what do we do with the R's? Divide them. And then, Dia, what do you think we do with the angles? Subtract them. So cis of A minus B. Multiply the R's. Subtract the angles. Whoops, yes, thank you. Divide the R's. Subtract the angles. We've done stuff kind of like this before. Exponents sort of work like that, right? When you're multiplying exponents, you add the exponents. Logs, properties of logs. When you're doing logs, the log of x times y is the log of x plus the log of y. So it's that same kind of thought that sometimes multiplication leads to addition, division leads to subtraction. This says the exact same thing that we just said. Like this box right here is exactly the same thing that we just boxed up there. So, I don't know. That looks a little more confusing to write it that way. Multiply the R's, and then treat the angles. Be careful. You either add them or subtract them. Okay, so let's do some examples of this. Write the value of all of that in reduced standard form. Okay, reduced standard form means A plus BI. So I could do A plus BI here and A plus BI here and then FOIL it and then combine, but like we know a shortcut now. Let's rewrite this in cis format first. So 2 cis 3 pi over 4 times 6 cis pi over 12. And now we get to use our shortcut. So rather than foiling everything out, 2 times 6 is 12. And then I'm going to write this one because I don't know what that is without showing a little more work here. 3 pi over 4 plus pi over 12. So what would that be? 9 twelfths plus 1 12th. How much can I do in my head without messing this up? 9 twelfths plus 1 12th is 10 twelfths. Yeah, one step at a time without showing work. 10 twelfths is 5 pi over 6. You guys know. You gotta show some work. Don't try to do it all in your head. I had this conversation with my 8th grader last night. They're learning complete the square. So he's not real happy about that. And he's the kid that wants to do everything in his head. I'm like, Micah, you can't do every step of complete the square in your head. Right? Like half it, square it, add it to both sides, and then factor, and then square root, and don't forget the plus or minus, and then move. Like, you've got to show some work. And so he did get some of them right, which is kind of unfortunate because I was hoping he'd get some of them wrong to prove my point. Thankfully, he missed a couple, so we could have the show your work conversation. So this is correct, and that's good as a polar form or as a trig form. So it'd be nice if it asked for that because we'd be done. But it wants it in standard form. So we've got to write out 12 cosine 5 pi over 6 plus I sine 5 pi over 6. And we get some more unit circle practice, which I know you all enjoy. Let's see, 5 pi over 6. Maybe the day will come where I don't have to draw the picture. Maybe not. Maybe that day will never come. Again, showing my work so that I get the problem right. And a chance to ask people questions. Michael, how about the cosine of 5 pi over 6? Good. And Zaynep, the sine of 5 pi over 6. Sine's the y-coordinate. So it's definitely positive. Michael had the long side with the x. This is the short side is the y. So short sides are 1/2. And then distribute the 12. So negative 6 root 3 plus 6i. I think that's easier than doing the unit circle stuff here and then foiling it all out with the I squared and collecting like terms. No, we have our shortcut way. It's just they wanted it back in standard form. So read the question carefully to know what kind of answer you want. Look at number 2, standard form. Number 3, standard form. So we got to keep going back to the I stuff. That gets us more unit circle practice. More popsicles to draw. Okay, number 2. Write that in reduced standard form. Okay, there's 3 things, but come on, this is the same type thing. 4 times 9 divided by 6. Cis of. This is a lot like exponents, right? You add the stuff in the top and subtract the one that's in the bottom. So this would be a place where some of you do this out to the side and don't show this step, and that's okay. But add the 2 that are multiplied, subtract the one that's divided. Let's see, 36 over 6 is 6. And then, out here I'm gonna do the common denominator thing. So that'd be 6 twelfths plus 14 twelfths minus 5/12. Again, some of this you could do in your head, but show enough work to get the answer right. 20 minus 5 is 15/12. Divide them both by 3, and we get 5 pi over... Oh, my key is wrong. It's okay. 5 pi over 4, right? Yeah. Key's wrong. Make sure I tell the other teachers that. This 5 pi over 4. And so now we just expand it, evaluate cosine and sine of 5 pi over 4. Again, one of these days, maybe they'll ask for it in trig form and we could leave our answer. But until then, we get to keep working on our unit circle. Caden, how about the cosine of 5 pi over 4?
Negative radical 2 over 2.
Good. And Dylan, the sine of 5 pi over 4?
Negative root 2 over 2.
Good. Also negative root 2 over 2. So distribute the 6. Negative 3 root 2 minus 3 root 2 I. Standard form as opposed to trig form. That one was definitely easier not doing the a plus bi first, right? Because that would have been a real mess up here to do that. But when we know that we can multiply the r's and add or subtract the angles, it goes fairly quickly. Okay, number 3, we got a power in there. So let's rewrite it as in the cis format. 2 cis pi over 4 cubed. Okay, we didn't explicitly say how to do this, but what do you think we do with the 2? Think about what cube means, and this is not a hard problem. Right? Cube means multiply it 3 times. So what should we do with the 2? Cube it. Now what should we do with the pi over 4? Add it 3 times. What's another way to say add it 3 times? Multiply by 3. I'm not going to write it all out, but that's what your brain kind of thinks. Cube it means multiply it 3 times. So yeah, I'd be adding that angle 3 times. That's a perfectly good way to say that, which means I would multiply it by 3. So 8 cis 3 pi over 4. Again, that's trig form. And we never ask you to leave it as that because, I don't know, one of these days we ought to, just to either make sure you're paying attention or just cut you a break from writing all this stuff out. But until that day, I get to just keep calling on people for unit circle review. Gabby's not here. Jameson's here. Jameson, how about the cosine of 3 pi over 4? Yes. And Ethan, the sine of 3 pi over 4? Positive root 2 over 2. Distribute the 8. Negative 4 root 2 plus 4 root 2i. Now, what you just did was, I don't know how to say that guy's name, DeMoivre. Getting into our French mathematicians. Oh, that's in calculus. We're doing a French mathematician as well. L'Hôpital. This is DeMoivre. I don't know. Does anybody take French and want to correct my pronunciation of that? Is that guy's name? I don't know. But what we did, we just used it. Like, we didn't call it that, but we used that. You cube or square or fourth or whatever the number, and then you multiply the angle. So you kind of stumbled into this guy's theorem. This would be one where, like, hey, why did he get to name that? That wasn't really that big a deal. Yeah, except he probably had a lot of stuff going into that. This is just kind of interesting here. Complex numbers, that's what we're doing. Analytic geometry, a lot of probability stuff. Born in the 1600s. Which, by the way, and calculus comes a little bit later. You're doing stuff now in school that's like not as old as some of the other stuff you learn. Like history is way back, although I guess U.S. history is more recent. Like the further you go in school, the more recent the stuff is. So now we're only a couple hundred years old, right? 1967 would be 300 years old, so 350, 360, somewhere in there. Oh, this was probably, I don't know, this is world history stuff. In his 20s, he moved to England to escape religious persecution, friend of Isaac Newton. There's this thing about who invented calculus, Newton or Leibniz, and because they each thought they did, that's a long story. This is the guy, this is hilarious, this is weird. I didn't remember it was him. As he grew older, he figured out that he was sleeping more and more each night. Because, you get old, you sleep more. And he basically sort of plotted that and sort of plotted out. And you're like, well, when I get to sleeping 24 hours a day, that must mean I'm dead. And so he correctly calculated the date of his death by extrapolating his sleep study when he got older, which is wild. And I don't know how far out that was, but it had to be pretty far out because he wasn't sleeping 23 hours a day at some point, but he just at some point calculated out it seems like I'm gonna reach 24 hours on that day. I don't know. Remember that? And when you get into your, I don't know when you make this study, 60s, 70s. What's that? How old was he? 87? Yeah, and I don't know how old he was when he made this prediction. It is very long life for that time. And so I figured he probably did that in his, 50s or 60s or something. I don't know. That's just wild that he thought of that and then that he made the prediction and then it came true. That's wild. All right, number 4. Write that in standard form. Okay, we're gonna change one of these. Let's do one more in standard form, and then we'll do one in trig form. Is there one in trig form? Oh, in trig form. There we go. We'll do number 5 in trig form as well. I don't know. You're welcome to look around. There you go. Okay, reduce standard form. So we cube the 4. 4 cubed is 64. We multiply the angle by 3, right? Because remember, if you don't memorize it, you just think cube means multiply it 3 times, which means add it 3 times, which means multiply by 3. 15 pi over 9, which that reduces, so that'd be 5 pi over 3. That's trig form. But we really like making you go back and forth here. So 4 cosine 5 pi over 3 plus I sine 5 pi over 3. And Jace colored his sticks, so it makes it hard to read his name. Jace, cosine of 5 pi over 3. Half. I'm giving you the hint here with the picture. Jacob, the sine of 5 pi over 3.
The sine of 5 pi over 3.
Uh-huh.
Yep. That's it.
You waiting for somebody to give you a hint?
2.
2?
There you go, Mr. Wolf.
It's over 2. That's about as close as we can get there. It's the y coordinate because it's sine. So it's negative for sure.
Okay, I think I got it now. Root 3 over 2.
There you go. Special thanks to someone over there.
No, nobody helped.
32 minus 32 root 3 times I. Number 5, let's change it to trig form just to spare Jacob the hassle of using his unit circle. So why don't you try number 5? This should be really quick because try number 5. Not big enough where you can see it. Guess you got to figure out what 5 to the 4th is, but other than that.
Imagine your life. So you went to school for 20 years to be a teacher, just to go back to school to work there for another 50 years. So you've just never left school.
I'll try to think of it.
Macy, what's 5 to the 4th? 5 to the 4th?
You've always been in school.
625. And Addie, what's 4 times 5 pi over 6?
I did 615.
So it'd be 20 pi over 6, which would simplify to 10 pi over 3. Because we add them. Well, we add them 4 times, which is multiplying by 4. Oh, and I said trig, so we'll leave it alone. But 10 pi over 3 is more than 2 pi, so we'd have to be careful here. That's an okay answer because of how I phrased the question. What's the same thing, or what's coterminal with 10 pi over 3? It's like if you did have to go to standard form, 4 pi over 3. You'd subtract 2 pi. And then you could get it into standard form if we wanted to. I mean, I suppose you could have left 10 pi over 3, but at some point you got to evaluate 10 pi over 3. Number 6, write that one in trig form. The trouble is right now it's in standard form, and I don't really want to, to fourth that, I would have to multiply it out. I don't want to do that. Let's change it into trig form, and then we can do the fourth thing a whole lot easier. Oh, you know what? It did say write it in standard form. So, well, let's change it to trig form first. So I'm going to graph it to figure out what this looks like. -3 and then negative root 3. 3 is bigger than root 3. Again, I like my picture to be, reasonably to scale. So -3, negative root 3. That helps me when it comes to getting the angle, if I'll draw it somewhat to scale. So r and theta, that's probably a 30, 60, 90 right triangle, but maybe you don't remember who goes where, and so you can just do it a squared plus b squared equals c squared. Let's see, 9 plus 3 is 12. Square root of 12 is 2 root 3. And now that I see that, I'm like, yes, that's right. The hypotenuse is twice as long as the short side in a 30, 60, 90 triangle. So maybe if I'd have recognized that earlier. Since it is a 30, 60, 90 triangle, that means this is a unit circle angle. So what is that angle? The shallow angle in the third quadrant, 7 over 6. So 2 root 3 cis 7 pi over 6 all to the 4th. Okay, so 2 root 3 to the 4th. Let's split that up and go 2 to the 4th, and then root 3 to the 4th, and then cis of 28 pi over 6. 2 to the 4th. I got that. That's 16. What about root 3 to the 4th? 9, right? Because root 3 squared is 3, and then 3 squared is 9. Or you just think about multiplying them all out, and you get 9. If you're a little bit higher power and you didn't want to have to do that, 3 to the 1/2 to the 4th, maybe that's a little easier way to think of it. 3 squared is 9. So however you get there, you get 9. So 144 cis 14 pi over 3. Uh-oh, I don't want to do 14 pi over 3. I need something coterminal with 14 pi over 3. Oh, very nice. So you undo, go backwards 2 pi twice, subtract 2 pi twice to get to 2 pi over 3. And now we're back to unit circle things. Cosine 2 pi over 3 plus I sine 2 pi over 3. You know what? Let's give Jacob a chance at redemption. How about that? Yeah, that's how kind I am to you, Jacob. I didn't want to let you leave on a sour note, a bad note. So cosine of 2 pi over 3.
Okay, Justin told me it's -30.
I doubt he said that. What's the cosine of 2 pi over 3?
-1/2.
It is -1/2. That is correct. And Katie, what's the sine of 2 pi over 3?
Root 3 over 2.
What'd you say? Okay, root 3 over 2. So half of 144 would be 72. So there's our answer in standard form. All right, last one. Oh, 9 to the 4th. But I got 3 to the 6th. Something's going on in here. I don't want to evaluate 9 to the 4th yet. I think I can figure out a better way. 9 to the 4th is what, 81 times 81, but I don't want to do that. And then cis of 4 pi over 3 minus 30 pi over 12. Wait a minute. Let's reduce the 6 and the 12 and make our life easier here. Make this 5 pi over 2. Three to the 6, that'd be 27 times 27. I don't want to do that. I'm trying to avoid.
27 times 3.
Well, that would be 3 to the 4th. But is there a better way to do this?
That's what I'm trying to figure out.
Just make it 3.
Let's write 9 as 3 squared.
What? Why not?
I'm trying to avoid having to do 27 times 3 times 3 times 3.
This one.
Uh-huh.
Why is it 3 pi over 2?
That's what 9 is.
That's a 5.
That's one.
I reduced the 6 and the 12 rather than doing, I guess I could have shown 30 pi over 12 and then reduced it to 5 pi over 2. Okay, but back to this 9 and 3 to big powers. I'm going to rewrite 9 as 3 squared. So that's 3 to the 8th over 3 to the 6th. That's much easier to deal with. So that would be 3 squared, that's 9. Again, you could have gotten there a bunch of different ways, like whatever 81 times 81 is. But this is an easier way. Cis, let's see, 4/3 minus 5/2, that would be 8/6 minus 15/6. Yeah, I think. 8 minus 15, that I can do. Negative 7 pi over 6. Maybe you leave negative 7 pi over 6 if you know where that is. So you're shaking your head like, nope, not doing that. So if you don't know where negative 7 pi over 6 is, what do you do to find a coterminal angle? Add 2 pi, which would be 5 pi over 6. And again, if you can visualize where negative 7 pi over 6 is, great. If you want to add 2 pi and get 5 pi over 6, also fine. You're at the same spot, coterminal. So 9 cosine 5 pi over 6 plus I sine 5 pi over 6. Do we think Jacob has paid his price, or do we click on him one more time? We'll let him go. I don't know that he earned anything, but by my grace, I will just let it go.
What do you mean, I earned a lot?
Kate, how about the cosine of 5 pi over 6? Negative root 3 over 2. And McKenna, the sine of 5 pi over 6? 1/2. So negative 9 root 3 over 2 plus 9/2 I. Okay. Yes, that was a lot of work. Think about what it would have taken without that shortcut thing. Like 9 to the 4th. I don't know what 9 to the 4th is. And then I'd have to multiply that out 4 times and multiply the bottom one out 6 times. And then, no. Like, that's why we really like this DeMoivre's shortcut. Okay, today's assignment is worksheet 2. And it's a turn in before you leave situation. But I think you still got like an hour left or so.
We don't have it yet.